Welcome all. So my name is Sujit Kumar. So today I'm going to discuss an important method for the estimation of nitrogen. That is nothing but a DUMA's method, as you see here. So this is a diagram. This is nothing but a diagram in the sense this is the experimentation setup for the finding the amount of nitrogen and the percentage of nitrogen in the organic compound. Okay, we can discuss very easy thing it is, and calculation purposes calculation is also very easy. Okay, see, so now here first let me explain this diagram. Okay, so this diagram has a long form glass tube. It contains with four parts actually. So in those four parts, one is a CuO gas, and the second one is organic compound with CuO and CuO also. CuO means copper oxide. Okay, we should use, and copper metal. So here this is a very important one. Copper metal is also very important. Okay, so what is happening? So we have to pass the CO2 through the all these four chambers. So this CuO gas, it can be used for the uniform heating, and also here in the second chamber, organic compound carbon oxide is there. These are the reactants here to produce the nitrogen gas, and CO means if any excess of organic compound, evaporated organic, it can be reacted with the coercive CO. Coercive means it's a rough surface of copper oxide, as well as if any of the nitrogen was uh, formed in form of the oxides of nitrogen, then it can be reacted with the copper metal and it can be converted into nitrogen. Means oxygens can be removed from the oxides of nitrogen and the N2 can be formed. So complete whatever the nitrogen content is present in the organic compound, that complete nitrogen content can be formed into the nitrogen gas here. And here this is a HGC, means mercury. It can prevent the KOH solution, prevent the entry of KOH solution inside. And here this is a KOH solution which can absorb the CO2. Okay, the excess of CO2, we are passing the CO2 here, and also some CO2 can be formed through this experiment, and water vapor also can be formed. That means here not only nitrogen gas, some water vapor also can be present. There is a possibility to present, that is called as aqueous tension. Okay, so now we can go to the reactions first. What is happening? So very simple reactions here. First of all, we have to take the organic compound, which is having nitrogen plus copper oxide. It can produce the CO2 plus H2O plus nitrogen and some oxides of nitrogen. Oxides of nitrogen can be formed. There is a possibility to form these oxides of nitrogen also. So how can we remove this? These oxides of nitrogen react with the copper metal here, and it can produce the CuO and nitrogen. So the complete nitrogen can be left. Okay, after reaction of CuO with organic compound formation of the CO2 and H2O, the complete nitrogen can be left out. So that nitrogen gas can be collected at the this is nitrometer. We can find out how much nitrogen can be formed, and here the volume of nitrogen, here nitrogen can be formed, and if we know the volume of nitrogen, we can easily find out the percentage of nitrogen. Okay, how can we find out? Let's see one calculation part one by one. So see, so very easy calculation part, it is very easy. So if you understand, you can understand very easily. So let's see. So first of all, I'm going to take the conditions. Gases are there. Nitrogen is a neutral gas, you know that. So nitrogen is a that nitrogen, we can take the conditions of STP conditions and given conditions. Means gases can apply the pressure and volume and at a different temperature. So that's why we have to take the two conditions. We know that STP is standard temperature and pressure, and the given conditions which are comes from the experiment. So let's take here two conditions, and before going to that, you should remember the let W grams be the known amount of the organic compound. Okay, so known amount of the organic compound it is. That's correct. Now coming to the two conditions at STP. At STP conditions, let us take P1. P1 is pressure, is equal to 760 mm of Hg, and temperature. Temperature is nothing but you can take it 273 kelvins. Okay, you know that 273 Kelvin. Next, V1. So we know that V1, volume of nitrogen at STP, we don't know. Okay, so we have to find out this volume of nitrogen at STP. So next conditions are, this is STP conditions at given conditions. So these conditions comes from the experiment, or in the problem only they will give. Okay, so let's take P2. Here P2 is nothing but the pressure of the gas. Okay, because in the pressure of the gas, even pressure of the water vapor is also there. So that's why we have to take the total pressure minus aqueous tension. So that is nothing but a P2. Next, T2, temperature. So this temperature also can be given in a problem. And V2, so volume of N2, volume of nitrogen gas given. These two are given. These two can be given in the problem, or these two are comes from the experiment. Okay, so we know that the formula, that is nothing but a P1 V1 by T1 equal to P2 V2 by T2. Right? So use this formula. P1 V1 by T1 is equal to P2 V2 by. So what is P1, what is T1? I think I have given here. Okay, so that's why V1 equal to, we have to find out this V1 equal to STP P2 into V2. So what is the T1 here? 273 Kelvin. 273 divided by T2. T2, V2, T2 comes from the experiment. Okay, T2 into P1. P1 how much? 760 mm of Hg. So this is the volume of N2 at STP. But we know that volume of nitrogen at STP, 1 mole of nitrogen at STP is 22,400 mS. Okay? So you know that 22,400 ml of N2 contains 28 grams of N2. Then V1 ml. This is the this volume for we have discovered from the experiment. Okay, so V1 means this much amount. Okay, V1 ml of N2 contains how many grams of nitrogen? Sorry, yes, how many grams of nitrogen we have to find out. So cross multiplication. So weight, okay, weight of nitrogen is equal to the weight of nitrogen. Simply calculate this one. V1 into 28 divided by 22,400 ml. So this is the weight of nitrogen. So we calculate the nitrogen weight. Okay, so you can apply the V1 value here. You can substitute what is going on. See, so weight of nitrogen is equal to V1 is P2 into V2 into 273 into 28 divided by 22,400. So 22,400 grams of weight of nitrogen we can get through this experiment. This is the formula. This is a formula. But we have to find out the percentage of nitrogen. Okay, so let's take percentage of nitrogen is equal to weight of nitrogen divided by total weight of the organic compound, because percentage in the sense we have to um, we have to find out overall weight. Okay, so weight of nitrogen divided by weight of organic compound into 100. So substitute this weight of nitrogen here, and you can I'm going to write here. So percentage of nitrogen is equal to weight of N. That means P2 into V2 into 273 into 28 divided by 22,400, 4 divided by W grams into 100. So we know that this ratio can be reciprocal when we go take this upper hand side. So the final percentage of nitrogen is equal to P2 into V2 into 273 into 28 divided by 22,400 into W grams into 100. Okay, so this is a percentage of nitrogen. So you can calculate, actually you will get another value also, but this is the formula for the finding of or estimation of nitrogen by using the DUMA's method. So this is the video, my dear all. So I think you can easily understood. Thank you so much for watching this video.